So now you know if I say something wrong, why. He just gave you the answer. Okay, when I was first asked to speak about declarative machine learning, and in 5 minutes to several hundred people, my immediate reaction was, this is going to be a hard job. So I decided to put together a story. Some of the story will sound familiar. Along the way, I'll try to get the message across to you, okay? Here's Bill. So the story is about Bill. Bill is somebody you probably know, and hey, some of you might actually be Bill. Bill has got a couple of very aggressive bosses, and they have heard these cool things called machine learning and data science, and then they asked him to go off and find out, to go ahead and build a data science initiative for their company, okay? So Bill is an enterprising little guy, as you can see. He starts going around and starting to hunt around what does it take to put together a data science initiative. As he walks through, he starts to hear all these terms, open source, performance tuning, a whole bunch of different things. And he sits down with it. Enterprising guy boils it down to 3 things that he cares about: employee skills, data, and hardware. And he realizes that if he brings it down to these 3 things, he'll then be able to go ahead and put together an initiative. And he starts off first with data science. So the data science employee skills, this is where he starts to get his first shock. He realizes that a data scientist now has to be a statistician, a machine learning person, has to know R, Python, and a whole slew of other things to actually make them into a real data science person. As he delves further and he starts looking at the world of data, the fact that the data is going to be high volume and the data is going to be coming at him with great speeds, that doesn't surprise him. But when he digs a little deeper, he realizes all these other characteristics about data: structured, unstructured. I've shown a few over here: sparse, dense. And he may not be an expert in machine learning, but his brain is already computing. It's telling him, wait a minute, those data scientists are hard to find. Now, does a data scientist now have to know all these different data characteristics and write each algorithm for each of these data characteristics? As he delves deeper and he starts going into hardware, he starts to realize that somebody comes along and tells him, hey, there are these GPUs. These machine learning algorithms take a very long time to learn. And somebody else tells him, for text processing, you have to go do FPGAs. So here he is, already starting to think through and basically say, data scientists are hard to find. I have to figure out a way for me to handle all these different data characteristics. And to make matters worse, he's also told that these data scientists first start to prototype on a laptop, and then when the data gets large, they have to suddenly move over into smaller, large clusters. So no background in this area, but smart enough to do this simple computation that these data scientists have to write these different algorithms for all these different data characteristics and all this different machinery. And he's smart enough to realize that these things continuously evolve. So he's sitting down at this point in time, feeling really lonely. And along comes an IBM salesman. I'm sure most of you guys have met those, okay? And the IBM salesman turns to him and he tells him very simply, he says, hey, look, this is the exact same thing in the 1970s the world faced with data management. They needed to figure out a way to be able to overcome a whole bunch of these things, and they invented SQL. And that brings me the introduction of what my title was about, declarative machine learning. The word declarative means exactly what it says, which is you declare. You tell the machine what to do, and then the machine figures out how to do it. And Bill is smart enough to realize that immediately. So going back to what happened in the 1970s, SQL got invented. There's an optimizer sitting in between, which goes ahead and optimizes and gets this execution plan based on all of the characteristics of data. And come in the 2000s, we do the same thing with machine learning. There is a way by which machine learning can be expressed in declarative ways so that the machinery does all the optimization for you. And before I go on to give you a brief introduction to SystemML, SystemML is an 8-year project that we did in research. We just recently donated it to GitHub. And I encourage all of you data scientists, especially those who are hands-on, to go download it and play with it, please. Okay? And to give you a feel for what it will be like, here is an arcane algorithm called non-negative matrix factorization, written against MapReduce, 1,500 lines of code. That exact same thing written in SystemML is 10 lines of code and better optimization. So I request you again to go back, download it, and have a look at it. Thank you very much.